Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss about the demultiplexer. In the last few videos, I have discussed about the multiplexer and what is its working process and what is its combinational circuit, and even I have discussed few gate questions to make you understand what kind of questions they will ask in the gate and whether you can answer it or not. So I hope you have watched all those videos. In this video I want to discuss about the demultiplexer. So let me discuss about the demultiplexer in detail. I will discuss what is a demultiplexer, how it is different for the multiplexer, and what is its truth table, what is its combinational circuit. All these things I will discuss in detail. So I request everyone to watch the complete video for better understanding. First, let me define what is a demultiplexer. It is a combinational circuit that performs the reverse operation of a multiplexer. Am I right or wrong? What they are saying? It is a combinational circuit that performs the reverse operation of a multiplexer. Can anyone tell me what is the multiplexer? Suppose let's take that I have a 4 by 1 multiplexer. Let me write it as mux. Multiplexer can even be called as a mux also. 4 by 1. What is meant by 4 by 1? We have 4 inputs, one output, and then we have two select lines. How I got two select lines? If I have 4 inputs, then log 4 base 2 select lines are possible, which is equal to 2. Are you able to understand? Now if you take the demultiplexer, it consists of n select lines. These are the select lines. If you have n select lines, let's take that I have 2 select lines. Okay, then they are saying the 2 power n output. So meaning is that you will have 4 outputs and 1 input. Now can you tell me what I can write it as? 1 by 4. Always we will write it as input cross output. Now 1 is the number of inputs and 4 is the output. This is a demux. Am I right or wrong? Now if you see that both of them, this is 4 by 1 mux and this is 1 by 4 demux, they are reverse of each one. Am I right or wrong? If you see that number of inputs in the mux is equal to number of outputs in the mux, and the number of outputs in the mux is equal to number of inputs in the demux. So it is different to means reverse of each other, but however the number of select lines are same. Am I right or wrong? So let me discuss about the demux further. If you see that it consists of n select lines and 2 power output lines, or you can even write it as if you have n outputs, okay, then you will have log n base 2 select lines. This is also you can write it. So let me give an example for 1 by 4 demux. Just now I have discussed, let me discuss it again. We have 1 by 4 demux, so I have 1 input and 4 outputs. Is it clear? And 2 select lines are possible. Am I right or wrong? Let me take the select lines as S0 and S1, and you have the input line, it is I, and the outputs can be written as Y0, Y1, Y2 and Y3. Okay, are you able to understand? We have 4 outputs, 1 input and 2 select lines. How to draw the combinational circuit? We have identified the inputs and outputs. Then what we have to do? We have to draw the truth table. From the truth table, we can generate the combinational circuit. Let me draw the truth table for the 1 by 4 demux. What are the input lines here? Is S0 and S1. Am I right or wrong? Then we have the output lines is there, which is Y0, Y1, Y2 and then Y3. Okay, now if you have 2 inputs, how many combinations are possible? 4 combinations are possible, such as 0, 0, 0, 1, 1, 0, 1, 1. Am I right or wrong? Now let me take the inputs and outputs. Now tell me, whenever it is 0 0, what output it produce? Then it will produce the y naught. Am I right or wrong? So y naught it produce and others it does not produce. Am I right or wrong? So y1, y2, y3 value will be 0 and y1 will be enabled. Whenever it is 0 1, y1 will be enabled and other it is 0. Okay, if it is 1 0, which is y2 and others are zeros, and similarly 1 1 means y3 will be enabled and others will be zeros. Is it clear? So this is the out truth table. Okay, now if we want to minimize this expression for each, how many functions outputs we got? 4 functions. So this is one function, this is another function, this is another function, and this is another function. Now let me take the minimized one. What I will do, I will take this y naught. Wherever it is 1 is there, those I will consider. Wherever it is 0, they are the max terms. So y naught can be represented as, okay, S0 complement, S1 complement, and I. Am I right or wrong? Because you are getting the input here. This is the input you are getting high. And here you will get the input. You are getting the input. Meaning is that 1 is enabled, meaning is what? Whatever the input is given, that will come from here. Are you able to understand? So into I. Am I right or wrong? Similarly, if you consider the y1, is it clear? y1 will give you what? S0 complement, S1 I. Similarly, y2 is equal to, if you see that y2, this is there. So which is S0, S1 complement I. Similarly, y3 is equal to S0, S1 I. Are you able to understand? Because this is the only minterm is there. And similarly, this is the minterm, this is the minterm, this is the minterm. Am I right or wrong? So we got the minimized expressions for the y0, y1, y2 and y3. Now using these expressions, we can design the combinational circuit for the demux. Let me draw the combinational circuit. I hope you have entered the or noted down the truth table. Now let me draw the combinational circuit for the demultiplexer. So what are the input lines will be there? There will be 3 input lines. Okay, you have the I, okay, S0, S1. Am I right or wrong? Then you have the y0 should come. How the y0 should come? You have to give the S0, meaning is that you have to give a NOT gate, okay, and S1 complement. Similarly, you will give a NOT gate here and you will take the I. All these things you will connect to a AND gate. Am I right? What is the fan in of this AND gate? The fan in is 3. Am I right? Because you have the 3 inputs. Similarly, this will produce the y0 as an output. Similarly, y1. y1 is what? S0 complement. So I will take a NOT gate from the S, and S1 is direct and I is direct. All these 3 I will connect to a AND gate. It will produce the output as y1. And similarly, y2. y2 is S0 directly. S1 complement. I will apply the NOT gate here, and I. All these 3 are connected to a AND gate. It will produce the output as y2. y3 is what? Directly S0, S1 and I. All are connected with the AND gate. It is producing the y3. Okay, so I hope you have understood the combinational circuit. Once you got the expressions from the truth table, it is very easy to construct the truth table. So this is a demux for 1 cross 4. Am I right? 1 input and 4 outputs and 2 select lines are there. I hope you have understood what is a demultiplexer, how it is different from the multiplexer, what is its combinational circuit, what is its truth table. All these things I hope you have understood. If you still have any doubts related to the demultiplexer, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.